All right, today we're going to be taking a look at systems of equations involving graphing. Now, for us in Algebra 1, systems of equations are two equations, and our goal is to see where their solution is. When we're graphing or any other situation, the solution is where those two lines meet. So we're going to take a look today at a couple of equations. We're going to graph them and find out where they intersect. Now, truthfully, in the future, when we do graphing, we want our equations that we graph to already be in slope-intercept form. It's not a normal or not the fastest way to change them, but for today's purposes, it's a good practice for us to convert standard form to slope-intercept. So we're going to start with 2x plus y equals 2. And again, as a reminder, to convert it to slope-intercept, I'm trying to get y alone. So the first thing I'm going to do is I'm going to subtract 2x from both sides. When I zero that out, I get y equals 2 minus 2x, or rewritten, y equals a negative 2x plus 2. Now, if you notice across the board, all three of our problems have the same exact initial equation. So you can go ahead and write y equals a negative 2x plus 2 in all three of those. That'll save us from having to do work later. We can also go ahead and graph. So again, when we graph, the plus 2 at the back tells us that our y-intercept is at 2. And then our slope of negative 2 tells us to go down 2 and right 1. Down 2 and right 1. And we can continue that pattern, and then we would draw a line through those points. That line represents y equals a negative 2x plus 2. All right, now the next thing we want to do is we want to move to our second equation, which is 6x plus 3y equals 6. And again, our first step is to move x. So I'm left with 3y equals, I'm going to go ahead and put the x in front, so a negative 6x plus 6. Again, our goal is to get y alone, so I'm going to divide everything by 3. So I get y equals negative 6x divided by 3 is negative 2x. 6 divided by 3 is positive 2. So this time, I would put 2 as my y-intercept, and I would go down 2 and right 1, down 2 and right 1, and you should notice that we have the exact same equation. Now, because we have the exact same equation, they're on top of each other, we have infinitely many solutions. Any number or any ordered pair on those lines is a solution to our problem because every spot touches every spot. Okay, and our description of those lines would be that we would have the same slope and the same intercept. So any line that has the same slope and the same intercept as another one is going to have infinitely many solutions. All right, now working on the second problem, we already have solved 2x plus y equals 2. Now we have x plus y equals 3. Again, I'm going to move the x to the other side. So I have y equals 3 minus x, or y equals a negative x plus 3. If you need to remind yourself, remember a negative x is the same as a negative 1x. So we start at positive 3, and we would go down 1, right 1, down 1, right 1, because our slope is negative 1. I would draw a line connecting those points, arrows on the end. Then I would go back and I would draw my other equation, which was negative 2x plus 2. So I'd go to 2 and I'd go down 2 and right 1, down 2 and right 1, and then I would draw a line connecting those points as well. And what you should notice is that there is a point where both lines intersect, which is right here. That ordered pair of negative 1, 4 is the solution. So it's not enough just to graph the lines. We have to be able to explain what the solution is. So our solution is negative 1, 4. That's the spot where the two lines meet. And our lines, again, have different slopes. And because they have different slopes and intercepts, they're going to intersect one time. All right, again, we're going to go to our last problem. Again, we're going to start at 2, go down 2 and write 1, down 2 and write 1. Let's fix that. Down 2 and write 1, and then we would draw a line connecting those again. Okay, and then we would go to our second problem. Our second problem says 4x plus 2y equals negative 4. Again, we want to move x. So now I have 4 minus 4x. So 2y equals a negative 4x minus 4. When I rewrite it, I'm going to divide all the parts again by 2 because I've got to get y by itself. Negative 4 divided by 2 is a negative 2x. Negative 4 divided by 2 is negative 2. So I start my point at negative 2 because that's my y-intercept, and then my slope says negative 2, so that's down 2 and right 1. I can't go down 2 and right 1 again, so I can go from my intercept of negative 2 and go up 2 and left 1. I'm going to draw a line connecting them. And what you should notice is that our two lines are parallel. Because they're parallel, we will have no solution. They will never cross and never meet. So again, what we're looking for is do the lines cross, and if they do, how many times? And our options are infinite solutions, they touch the entire time, one solution where they meet at one point, or no solution where they don't meet at all. And for no solution, we have the same slope and different intercept. I hope this helps. Please let your teacher know if you have any questions. We're here to help you out.